Hello, good afternoon, everybody. Thank you for coming to ThinkBox. Thank you for waiting so patiently. My name is Ian Charnas. I'm the Director of Innovation and Technology. And today I'm going to also be wearing the hat of host and MC for today's event, where you're going to get a chance to hear directly from students, staff, and faculty working to innovate here at ThinkBox. You're going to hear from student startups. You're going to hear from faculty startups. You're going to hear from faculty working on experiential learning opportunities for academic courses and all points in between. We have a great lineup of speakers for you here today, and I'm eager to get the first one up here. But before we do, I want to share just a very short introduction about ThinkBox, including, for those of you who are already familiar with ThinkBox, some things you may have never seen before. Now, depending on how you entered the building today, you may not have had a chance to see it from the outside, but this is where we are at. This is a large 7-story, 50,000 square foot facility that houses the university's Makerspace and Innovation Center. It's a very popular space on campus. We get about 7,000 visits a month. We've gotten over 500,000 visits since opening in 2012. It's especially popular with our students. Last year, almost half of all undergraduate students visited ThinkBox at least once. And we saw among our student users, when we surveyed them, that 75%, 3/4 of them, said ThinkBox was a major factor in their decision to attend Case Western Reserve University. All of the resources here are freely available to all of our students, our staff, and our faculty. But not only that, ThinkBox is also free and open to the public. There's no membership fees, there's no hourly fee to use the equipment, there's no fee for storage, there's no fee for taking the workshops or classes, and so on. It's very rare for a private university to open up a facility like this to the general public, especially for free. In fact, this is the world's largest open access makerspace and innovation center. It's something that we're very proud to offer, these world-class resources to makers and innovators in Northeast Ohio, including the ones we're about to hear from today. A lot of people know ThinkBox for our equipment. We have a complete metal shop and a complete wood shop. We have 3D printing and electronics. We have textiles working equipment. We have laser cutters. We have a water jet cutter. We have welding equipment. And when we see spaces like this that have millions of dollars of high-tech equipment, some part of our minds say, oh, this is for engineers. We think this is just for engineers. And honestly, that's the single biggest myth that we have to dispel. This is a project we did, a collaboration with some faculty over in the School of Medicine here at the university. This was a UVC decontamination chamber for N95 masks. This was a COVID relief project. This was another COVID relief project. It was a project to come up with a way to color code IV lines. If you have many IV lines, you need to keep track of which one is which, especially useful during emergency medicine. This is an inspirometer. It's an electronic device that replaces the ball and tube you may have seen if you've ever had a surgery and you've been laying in the bed and the doctor tells you to blow into the ball and tube to help exercise your lungs and help prevent you from getting pneumonia. And of course we say yes, and the doctor leaves the room, and we go back to watching Netflix. So this device actually lets our physician know if we're actually following the instructions. Here's a project from a couple of projects from biology. On the left, there's a DIY version of something called a peristaltic pump. It's a way to pump liquids where the pump impellers never touch the media, never touch the liquid. Very, very useful, also very, very expensive. So this DIY version helps to provide an alternative. On the right, there's a model of some bronchioles that's used in anatomy instruction. But not only that, also math. Here's a multivariate calculus class that used ThinkBox to create 3D models of the surfaces, the three-dimensional surfaces that they were studying in class to help students get more of a gut feeling for what are we really working with here, a true enrichment activity. Here's a project we did with the School of Dental Medicine. Their students regularly 3D print these positives, and they use them to thermoform invisible aligners. They make Invisaligners with these. That's what that means. And it's part of their dental practice, and it now requires 3D printing. It used to be that they would put that amalgam in your mouth and we would all choke a little bit on it. But these days they have 3D scanners. It's a much more pleasant experience if you ever get to experience that. But not only that, from the world of art, we have animation. We had a student who 3D printed all these little models of a face and decorated them so that they could be used in a stop motion animation video. We have psychology on the left here. That's a special kind of IQ test. It's a game. It's a special kind of IQ game for nonverbal patients. And on the right, there's an exhibit that you can now see at the Cleveland Museum of Natural History. This is a skull puzzle that fits together with magnets and helps at a simple level to illustrate the difficulty in reassembling something that you find underground. But that's not all. From the world of fine art, this was a composition that was laser cut and then hand drawn by a student from the Cleveland Institute of Art. And from our own Case Western Reserve University Department of Art and Art History, we have this project here. It was a collaboration with Art History, with ThinkBox, and with the Cleveland Museum of Art to do a perfect 3D scan and replica of a sculpture of Krishna from, I believe, Southeast Cambodia. So as you can see, it's not just engineering. And as our speakers will help illustrate, no matter your area of expertise, it's often that you'll find a use for the equipment and other resources you'll find here at ThinkBox. And with that bit of intro out of the way, up first, I'd like to invite esteemed Professor Jill Davis to come on up and tell us a little bit about the theater class she brought to ThinkBox for an experiential learning opportunity she created. Jill, come on up. You can, yeah.
Nice. Okay.
You can come on up.
I'm that person who never remembers what slides I submitted. You know, it's funny that you started this with engineering because that's how I was introduced to ThinkBox. I teach in the Department of Theater here, and we have many double majors or people in another major just interested in theater. And I seem to be getting several mechanical engineering students in my design class. And I have them do model building to make theater models, to do their set designs. And I'm not standing anywhere near the microphone. I'm a loud person. Should I be near the microphone? Okay, I'm sorry. And I went to art school, 30 years ago and learned a lot of using my little X-Acto knife and all these things. And a few engineering students said, cool, I'll probably just laser cut that at ThinkBox. What does, and that was back when it was at Glennon, early days, and I started learning about ThinkBox. So I brought a model. I realize it's very small, but I have pictures of it so you can see them. But there's something about these tiny little things that are always kind of charming and people want to see. The scale model is alive and well in American theater. Even though I can do a lot of computer modeling, I 3D draft and make that happen. When I look to the professionals, I always see them starting with a scale model, a little physical thing. The directors play with them. It's the best way to represent the whole set. And so this helps me. Just do this down arrow. This is, we recently moved into the Malt Center of Performing Arts 3 years ago. And this was our first show, Arcadia. And this is my scale model of the show. So in reality, it's about this big. It's 1/4 inch equals 1 foot. And that's what I do to work it out. And for this, I mostly used, you can see my desk where I put it all together there. I use laser cutters to cut out these windows, put them together. Little 3D printing for some of these furniture pieces. Laser cutter is still my favorite. I like to put things together and be able to paint them. Some people have asked me, why don't I just 3D print the whole model? And I guess I should try that, but I'm used to paint it if I have a whole thing to try to get in there and paint, but if I can paint the pieces and then put it together, that's what still makes sense to me. And I have my students come over to use it too. So just, let's see, there's the actual set on stage. So when I show them both to you in the same scale, they look pretty much the same. So I thought I would also, wait, let me go back and make sure. Yes, people, actual, yes, that's the real set on stage. Well, thank you, thank you. And
I don't know if we're supposed to interrupt, but
please do.
how did you get the files then to make the scale model? Because the replication is phenomenal.
That's what I do. I draft little pieces and then put them into Corel Draw, which is what our laser cutters like to do. So that's kind of what I teach my set designers to do, to understand the 1/4 inch scale equals 1 foot. Draft a version that's the right size, so those windows are about this big. And so I drew that out in a drafting program, had it laser cut and put it together. See if I can go backwards again. Model, set, and then just to make it even more fun, model and set. I started liking to do that, get a little picture to compare the sizes.
Is this robust enough you could pass it around?
You can. The little pieces of furniture are going to tumble around. They're not glued down because that set moves around. But don't worry, if the little pieces of furniture tumble around, just let it happen. You can play with it. But yeah, and I'll show you that model next, the one that's being passed around. This was for the Seagull for our MFA class. So this theater is downtown at Playhouse Square. And you have to build the theater itself, too. And that was the first project. I had my set design class here a week ago. And staff members from ThinkBox showed them how to set up a file for the laser cutter. And so they've made a model box, we always call it that. And we use foam core. We like it nice and lightweight. We pin it together, so if you have to carry it around or flatten it. I mean, set designers mail these things, to the theaters. I've received them before when I used to work in the theater. A model box this big, and it's just filled with packing peanuts. Take it apart and hope we haven't destroyed it. So this one, I've just did them side by side this time, the model over there and the real set here. And I'm not sure what else to say about this one. I do things like, I've certainly plenty of times have hand painted this kind of thing. This time I printed it. I'm often the painter who paints the real thing anyway, so I'm pretty adept at that. And I was just saying to Ian, the little trees and the model that's passing, I did buy those, but I'm certain I could 3D print those. I haven't tried that yet. Let's see. And just one more time. That's the reason the furniture is not glued down, because the furniture changes in different scenes for that. So I just wanted to show you a different set. And did I do it again?
Do you do marking with the actors on your furniture, or is it just
Not really. In professional theater, they tend to be in the rehearsal hall with them, so they can always refer to it. In school, a lot of times, the rehearsal hall is also a classroom, and all these things are happening, and it kind of ends up over in the corner. They like to see it at first, but doesn't get quite as used. But I will say, in the professional world, they're really used, especially if they do something like a turntable. We need to see it do this, and we need to see it this way. What did I bring up this? Oh, this is a student's project, one of their final projects from school. This did not get realized. This is the final result of this. But the model box it's in is for our theater at school. So they learn how to make that in the proper scale and figure out what. And I'm sure there was a combination of laser cutting and 3D printing in there. And I have one more, I think, one more student's project. The show is called Eurydice. I mean, it's a pretty creative, lot of different ways to go. I mean, this particular set and this one were for the same show. Wow. So there's a lot of variety. And we've got more students coming over to ThinkBox.
Excellent.
Very cool. So what's the students' experience like when they come to ThinkBox? Do they find it challenging, or do they find it easy to?
They're very adept at it. Every once in a while, I have a student, they're kind of intimidated. That's engineering. I've never been over there, kind of like Ian said. And the first time I bring them over as a class, sometimes some have already been here, But we kind of have the space to ourselves, and somebody does a tutorial and shows them. They say, oh, okay. And then they're off and running.
I think we have time for a question or two, and I think we have a mic that we can pass around. Does anyone have a question they'd like to?
Sorry, I'm not so great at staying on mic. Go ahead. If we can.
We have a microphone here.
Oh, sorry.
So we can hear you.
Hello.
Hi.
Okay. I know you said like they have a class. You bring your class over and they teach them how to do it. They have a tutorial. But are there any like architectural people that can show you how to do it, or say if you have something complex and you want something in your mind on the graph, how do you like? Is there anyone there to help you for that?
I guess that's what I'm there for. I'm teaching them the design part. A lot of times, because in one class, for me to cover every single possible thing they need to build, a lot of times if they show me examples of what they're hoping to make, if it's a specialty item that they can't find, I'll help them 3D draft it. Because it could easily turn into a 3D drafting course.
And we also have an opportunity, if folks are thinking about a special event they'd like to host, there is an opportunity to talk to ThinkBox staff members who may be able to find a content expert who could be that person. So if you're not in an academic class where you would be learning that, there's other avenues as well.
What's your background? Are you an industrial designer? Are you an architect? Are you an engineer? Are you all three? And what programs do you use?
I am a theater designer. So I went to school in visual arts, actually, and then eventually got my MFA in scenic design in theater. So I really meant it. My background was in using, X-Acto knives and paint and that kind of thing. And what programs do I use? I draft with Vectorworks. It's a program that covers a lot of areas, but there is a version of it called Spotlight that's pretty much geared for the entertainment industry.
Well, please join me in, you have one more question?
It's actually kind of for you.
Okay.
If a student comes over for a class or on their own to do something, how are the materials funded, or do they get an allotment, or?
I think there's a combination, and I'll let you answer part of it. I unfortunately use materials they don't typically use here, mat board and foam core. So I'm providing / charging a lab fee for that. But I think you provide some, right?
Yeah, that's a great question. We have a variety of materials available at ThinkBox that are purchasable at cost, but many people will bring in their own materials. So in terms of funding for students, we do have a student project fund, and students can apply for funding for unique and interesting projects. We also have a community project fund. We're excited to reopen as soon as we can. And we have a faculty fellowship fund. So there's several options for funding as well.
And the Welcome Fund makes it, and don't forget the Welcome Fund, which gives you $50 to sort of explore. If you're just getting your feet wet and you want to try things out, but you don't necessarily want to pay for that experiment, there is a running, what we call the Welcome Fund, which is really targeted at new users, but it's available, I think, to anybody.
Well, with that, let's join me in thanking Jill Davis for coming here and spending time with us here today. And next up, I would like to invite Allison Payne up here to talk about a really unique project with infant catheterization. Please join me in welcoming Allison.
Thank you. All right. So my name is Allison Payne. I'm a neonatologist over at Rainbow, so I take care of the itty bitties, all babies all the time. And I'm here to present a project of one of our recently graduated fellows. So in neonatology, we're caring for newborn infants who may present as ill soon after birth, or they're facing congenital anomalies or preterm and can be born as early as 3 months prior to their expected due dates. Their procedures and vascular access in this population can be very challenging. And so we use the differences in newborn physiology, and we're working to use additional tools as they come out to our advantage in caring for these infants. So point-of-care ultrasound, or POCUS, takes a familiar modality of imaging from the radiology suite to the patient's bedside. POCUS can be used to answer goal-directed questions and can decrease radiation exposure, improve safety, diagnostic accuracy, and reduce procedural complications, including those that stem from prolonged procedures while awaiting portable plain films to be taken. There are several indications that we can use POCUS for in neonatology. The problem is currently a lack of expertise. So we have kind of a bottom-up philosophy to POCUS, where the people who know how to use it most are really the youngest people in the system and the youngest trainees. Medical students sometimes are knowing more than their senior faculty as far as the use of POCUS. And so really trying to, CareBest project really focused on trying to build in a curriculum for POCUS and a workshop series. So, Dr. Carr's real intention was to focus our use of ultrasound initially to bladder scans, identifying landmarks and optimizing lumbar punctures, or kind of epidural placements, and then for use in the placement and monitoring of umbilical line placements. So babies are born with this kind of a vascular system. While they're inside, they are still connected to the placenta, which is where they're getting all of their circulation from. As soon as the baby is born, that's when you kind of clamp the cord, cut it, and then the baby has to circulate all on its own. But those vessels remain patent for a few days.
So it's labeled there umbilicus, we would call the belly button?
Yes. Yep. And so those vessels stay patent for a few days until they naturally clamp down and then become more ligaments in you and I. And so what CareBeth found when she was trying to set up her curriculum was that the available models or phantoms for practicing procedures in neonates were either lacking entirely, we have a very specific population, or very cost prohibitive for a small training program like ours. So Dr. Carr started working with one of our pediatric radiologists, Dr. Nicholas, and another pediatric emergency physician with POCUS expertise to develop appropriate phantoms for ultrasound training, and found ThinkBox as a resource and partner.
Say, Allison,
Yeah.
for those of us who aren't familiar, what is a phantom?
It's basically a model, is all it boils down to. I'm not sure that there's a technical, more specific kind of definition than that.
So you use it as a stand-in for the patient when practicing ultrasound?
Yep. So what the curriculum that CareBeth is trying to develop is to really, as a curriculum of workshops, to get our trainees practice in handling the ultrasound and identifying landmarks. And to do that, the best way to do it is going to be with an appropriately sized model and not just a pile of gel, to get the feel right, know when you're slipping off sides of the baby and that kind of thing. Okay?
Thank you.
Sure. So the first step was really to print a true-to-size mold of a newborn torso using a reconstructed CT imaging set. And the mold was, and then a CT reconstructed newborn liver was also printed. And then the intention was to print a heart and central vascular system. This became more complex than I think we were ready for quite out of the gate. So using the torso and liver molds, ballistic gel, stearine, gel microspheres, and gel dye were melted and then poured into the mold. Latex tubing was then placed inside the liver mold to stimulate a vessel. That's that part here. And then the liver phantom was encased in a saline wrap to mimic the liver capsule, which is kind of anatomic landmarks, and placed in the torso. So B is the liver, D is the cardiac chamber, and then C is the rest of the torso. So in these early stages, a fluid-filled latex balloon, that's C, was simulated the cardiac chamber. It was then popped and then kind of created a negative space that we could use. And then the phantoms were then cooled and unmolded. And so this is that's what you're seeing is the back side on the left, and then the front side flipping over.
So this looks like an infant to an ultrasound.
Yes. Yep. So evaluating the phantom side by side with ultrasound from patient to model is yielded these images. So on the left is a real patient, with A being the cardiac chamber, C the liver, and B the umbilical venous catheter emerging through the liver and into the right atrium. And on the right is our phantom torso, which although it's slightly more homogeneous, if you look real closely, in texture is a very close representation. And so we were able to use this in launching our POCUS workshops and curriculum with good response and success. And so then we went back to this and trying to print the heart vessel combination. So part of the issue here was in printing this, where we're trying to mimic certain textures and thicknesses of cardiac chamber walls and vessel walls. And so the walls were actually too thin to support the material once in the ballistic gel, was one of the problems. So kind of crushed it. Also, this is fairly complex. But in printing, you have to have the infrastructure, and trying to get the infrastructure out of the model was creating some problems, and it was getting caught up in the vessels and preventing us from using them as we were hoping. So multiple iterations later, they did finally achieve this, and with a degree of flexibility while still maintaining its kind of ability to bear weight within the gel. And so this is our model now. So that you've got the backside of the torso up above, and then in an effort to try and hide all of the components, because you can't see through a baby, made it black and dyed it so that we would actually have some obscuration of the internal pieces. And so this is kind of a progression. This is our trainees using this within our workshops. So you're starting to see, so you can see over here, the catheter is just starting to emerge out of the portal venous system. And then it goes too far into the cardiac chamber. And where we want it to sit is kind of right here, low in the right atrium, in order for there not to be a risk of perforation to the cardiac chambers.
So this is a student practicing inserting a catheter and then watching the ultrasound?
Yes. So ideally I'd have a movie, but this is what Carabeth was able to get me. So
This is a picture of a portal venograph procedure.
Mm-hmm.
My daughter is scheduled to get one in a couple weeks. Now that people are getting lots of practice.
So we are specifically, staying with just the babies because that umbilical vein really is only accessible then. But yeah, they're doing something similar.
So this way the clinicians can get practice on the model before they ever touch a human.
Exactly. Yep.
That sounds great.
All right. Any other questions?
Yeah, we have time for a few questions. I think we could probably send the mic around. Anyone want to be brave and offer the first question? Allison?
So this is for fellows or
Yes.
residents?
So,
Rotating?
so you go through medical school and then you do residency, where you become a pediatrician, and then fellows or pediatricians who are learning to be neonatologists. So kind of dealing with 30-year-old learners.
So is there any future where you'd collaborate with like Neomed or somebody to do training outside of Rainbow before they get to you? Or what's the future state of this?
So there are commercial models that exist. I can't say I've ever had my hands on one. I don't know that they're really significantly any different than ours. So one of the pieces of Carabeth's scientific portion of her project was actually to try and do a validation study with radiology to look at the textures and make sure we're kind of as realistic as possible. I mean, in an ideal world, you'd make everything move and have the heart beating, and it's not going to happen. At least not in my mind right now. I suppose somebody can create that. There's in our design team. So we had 2 physicians from UH, one from Akron Children's. So we've already kind of got a regional kind of idea. There are 3 neonatology fellowships within the city of Cleveland. We have not necessarily yet offered to build everybody POCUS torsos, but that's kind of where you could go with it. The part of Carabeth designing her own model was really to prove that you could do this at a local level and to share those files and then have people go and use their crock pots and ballistic gel and create a model. And that if you had the files to kind of print some of the infrastructure of the pieces, that they could build their own without spending $5,000 in startup fees, which training programs like mine don't have. I get $7,000 a year to support all of my fellows and their academic interests.
So have you made open source plans yet, and will you?
Not at this
disseminate
point. It's through something called MedEd Portal. Carabeth's able to share the general process. I don't know that she's shared the actual files at this point.
Did you have a question, Dr. Newman?
So if I understood correctly, you're using a balloon to create a void as part of your model building.
Mhm.
So it reminded me of a lost wax process in casting. I wonder if there is a material that you could rapid prototype that would, say, melt out after, so you get the exact shape that you want, and then with the other stuff around, maybe do a lost wax equivalent at low temperature, perhaps?
I
Yeah.
suppose, yeah.
There are 3D wax printers, so you could do that. It would allow you to get a more complex shapes than a balloon. But this was fantastic.
These are some of the other models that CareBeth has made over time. Not all of them were printed, but the three kind of spherical looking things, those are basically just balloons inside of a cylinder to represent bladders. The top is that cardiac chamber after it's been perforated. The bottom is the torso. On the right side, on the top is just some simulation of peripheral vessels, and then the bottom is kind of the first attempt at getting that full print into a 3D gel to see how it would tolerate it.
So I have a related question. So when you talked about going through a set of iterations to get the vasculature,
Mhm.
I'm presuming that that required a lot of conversation between the ThinkBox staff who were running the printer. Was that a challenge, or was that something that was easily over?
So I know that CareBeth was back and forth here quite a bit, and there were lots of email exchanges, and kind of there was stuff happening here with students that were then kind of giving CareBeth new iterations to kind of play with.
So were these students who worked at ThinkBox or students from the medical school? Or
No,
both?
ThinkBox.
Okay.
Mhm.
Well, please join me in thanking Dr. Payne for sharing time today. And if I can not trip over the cord this time, please join me in welcoming Professor Wyatt Newman to coming up and share a little bit about a road prints project.
Thank you. All right, this is an attempt to bring some higher technology to what's a fairly mundane process, road painting. All right, we're all familiar with those signs on the road, crosswalks and stop lines and turn arrows and school zones and bike lanes and such. The way that this is done is really very rudimentary. I'll tell you more about that. First, who are we and what are we? This is our system. This is the second generation. We have a third generation system just coming online. It's an industrial robot connected to a big honkin' truck, a Ford F550, and it has on it an air compressor and paint and beads and painting system. We put it all together with computers and sensors and automate the process of doing road painting. This is who we are. At the top there is my co-founder, Sam Bell. Myself, and our CEO is Dan Pendergast, whom many of you probably know since he's the interim head of tech transfer here at Case. This is our technical crew, of course, myself and Sam Bell there. And on the far left and far right are Joe Cressman and Quan Nguyen, who are recent Case Masters graduates in engineering who joined Road Prints. And so that's our team. And this is Electra, our third generation system that was just delivered in the spring, and we're still building up the equipment on top of that, so she's not out on the road yet. This is the process that's normally done. This is the customer pain point here. You'll see this, typically there's a crew of people out on the road painting with stencils. A problem with this is that they often get maimed or killed. All right. Standing on the road is terrifying. And they're out there having to stand on the road, and people don't always pay attention to those orange cones. So it is one of the most hazardous jobs. Also, people don't want to do it. It's often done in blistering hot weather or 2 a.m. in the morning. It's hard work, long hours. They have trouble recruiting people. It's an aging workforce. Nobody wants to do it. So our notion is to instead put them inside the cab of a truck, listen to their tunes, turn on the air conditioning, have the robot do the painting. This is a picture I found from the 1920s, a road painting crew. You can see them standing there. I think it's a Model T era vehicle and a plastic stencil. Then I was driving around on the west side of Cleveland and during pandemic and saw this road crew out painting, and it looks pretty much the same. There's their plywood stencil, and they're standing on the road painting. So what we want to do, what we have done actually, is we put together a solution that consists of excuse me, a collection of commercial off-the-shelf components. Like I mentioned, the Ford F-550, it's a Yaskawa industrial robot arm, it's Graco painting equipment. So this is all, leaders in their fields. We knit them together in a novel configuration, add the sensors, calibration, and the software in order to make it an automated painting system. We recently received a patent just last March, so that was exciting for us and helps a lot with our appeals for funding. So we actually have some intellectual property. This is, does it autoplay? Oh, it does. Thank you. So a little illustration of how it works. This was trying to find people who are willing to let you paint on their pavements turns out to be hard. This is a Center for Families and Children, and they're putting in an electric vehicle charging spot. We said, ooh, can we paint EV only? And they said, sure. So we got to paint on their pavement. The letters come out nice and crisp, as you can see here. We're learning about some of this painting technology. The paint is compressed with fairly high pressure, a couple thousand PSI, and it comes out in a very distinct fan shape. It's like a thin triangle. This was painting in Metro Parks in a parking lot. They said, yeah, you can come here and redo our parking lot. We don't think this is really our big business here, but it gave us a chance. Those are 18-foot lines we're putting down. Here in the handicap spot, we put down, changed colors, painted blue box, put the handicap logo on top of it, and the cross hatching over here. Hopefully we'll see a scene where you get some idea of... Oh, yeah, thanks.
This is my favorite.
Okay. So hopefully you'll get to see, it goes by kind of quick, but here. So the operator is moving a virtual stencil. It's an electronic stencil. We get a live camera view. The robot holds the camera way up in the air, about 12 feet up in the air, and looks down at the site. And then the operator can overlay the electronic stencil on it and say, yeah, I like it there, go paint it. This is on Lee Road in Cleveland Heights. They let us do, this is only chalk at this point, so it washes away. But, they let us go on Lee Road and do this painting. And it came out quite nice. One of the things that I was surprised at is the traffic going by, they don't even care. Right, so, okay, so robots paint the road. In fact, we had this parked at the Stone Oven parking lot one time. Guy came up, he's staring at it, says, what is this thing? Oh, it's a robot that paints roads. And he goes, oh, I always wondered how they did that. I said, no, nobody does it that way. Here was another demonstration at the Cleveland Skating Club. They said, yeah, we want you to paint slow over here. People come tearing through there, it's too fast. First step that we do is a laser scan. So we have a LiDAR mounted on the arm sweeps around, we get this three-dimensional plot. You can see from the false color on there, we can see the curb, we can see the trees, we can see the people, but we can also see the undulation. This is a retroreflective bead. It is common to put down a layer of this bead on wet paint because it makes it bright at night. Your headlights hit it, bounces back at you, and it jumps out at you. But it's like pumping sand, so we kind of had to learn how to do that as well. But now the robot can put down the paint and the bead as well. This is for layout. If you're doing a repave and you're painting on top of it, you have to lay out the center lines and such all over again. The surveying task is also quite dangerous. What they do right now is they run back and forth from edge to edge with one of these Da Vinci wheels, and they read off, this is how far it is, and come back, split the difference, come back with a spray can, and put a little spot of paint there. And keep that up hundreds of times, running back and forth across the road, also extremely dangerous. So here you can sit in the cab, use the camera as your measuring system, and you say, there's one end, there's the other end, split the difference, put a spot there. This is setting out cones. So we have sort of a Swiss Army knife on the end. It has the bead head, the paint head, the gripper. Those fingers, I think, were made here in ThinkBox. A lot of our parts were, both machined metal parts and plastic parts that we're using. Often just, connecting things. I need to put the camera onto the arm, and you have to solve that problem. And that's conveniently done with rapid prototyping. Now we're starting to grow up a little bit. We're painting real turn arrows with actual paint on Euclid Avenue in the city of Cleveland, and having the Cleveland folks here do the actual painting, which they catch on right away because it's really very intuitive. Just take what you see, choose your icon, move it around until you like the way it lines up, and say paint. This is on Payne Avenue. We painted these bike lanes with the green boxes and the bike logos and the arrows that go on top of them. Looking at just right by. No, just doesn't care. I guess that's just how they do it. So this worked out really well. What's not on here is some more recent work. If you drive down Euclid Avenue and you see the bus only, the fresh bright white ones, that's us. We're not in the road painting business, we're in the equipment business. But part of that is we have to go out and do beta testing, and we have to get people comfortable with the notion. The city of Cleveland actually is increasingly comfortable, and I'm hopeful that they will be one of our early adopters. We're just at the threshold of selling our first system, so that's pretty exciting. And we anticipate going into production of these in the very near future. It's a good time to build it over the winter because painting season is mostly in the summer, except in the south they can go year round. Alaska gets like a handful of weeks a year to go painting. Canada as well, very limited painting season. And there's another, they just don't care. Yeah, robots paint the road. So this did work out well. Like I said, we're pressing our plans. We're going next week. We're painting intersections on Bridge Avenue on the west side. And so if you go over there and see your fresh white intersections, that presumably will be us. So in quick recap, the need is we have people on the road doing painting. It's expensive. It's dangerous. And, there's, like I say, tough to get a workforce willing to do it. Our solution is, well, we can't start from scratch and start, build big manufacturing stuff, but we do have our contract manufacturing is a company in Akron, QT Equipment, that has their expertise is building up specialty trucks. Right? I didn't even realize this was an industry, but if you get, an ambulance, a bucket lift, a party bus, all of those things, they started with, it's called a strip chassis. You got a cab and nothing on the back, and then you build that up into the specialty equipment. So we went to them and said, can you put a robot on a truck? And they said, sure. No one had ever done it, but they were confident they could, and now they've done 3 of them. And so they are our contract manufacturer. Like I mentioned, we put on then the computers, the sensors, all the software, human interfaces, and that comes up with the vehicle. One of our prospective customers did his own return on investment computation, roughly speaking, payback in about a year, which is pretty attractive. And that's not counting the cost of killing people, right? The U.S. Department of Transportation has to, they say economics is the dismal science, so they have to assign a cost to human life. $10 million. That's the cost they put on a road worker. So you save one road worker's life, you can buy a lot of our machines. So that's not even in that return on investment. This is where we anticipate selling to initially, because QT Equipment has a service region in these 6 states. That's our preference for the beginning. But nationwide, where it's really hard to do these things. How do you know what the market is for a product that never existed? But with the best effort, we think about 1.6 billion U.S. total addressable market. Of course, some fraction of that will be adopters. But that's for the U.S. We've also gotten interest from Canada, from Middle East, from Hong Kong, from New Zealand. So, and this is just people finding us on our YouTube, so we haven't even really started marketing yet. So I think there will be worldwide interest in this. Certainly the East, like Japan and Europe, uses a lot more paint on the roads than we do. So we think that will be interesting. This is us, roadprints.com, roadprints with a Z because the S was taken. So that's it. All right, so any questions?
We have time for a few questions if we still have that microphone.
I saw the green boxes you guys did. I'm a runner, and so I ran in the morning, and I was like, these really like green boxes look so nice, and I felt safe running on these, like, because it's so dark in the morning. That was just a comment, but just saying I saw your workout there. But the question I guess I had was going back to the like economic side of it or jobs, and I missed part of that slide, but how does it compare when you look at like how many people it takes to do a road painting job now versus like I think you said 2 FTEs on to operate this, and then do you see opportunities for people to get jobs beyond just like the driving of the truck? Like, are there opportunities to learn the skills required to like the maintenance of the machines and that kind of thing? Like, you know, I'm all for like, and if it sounds like a really awesome product, but also how do we like keep people's jobs too, or like?
Yes, thank you. So we are becoming more familiar with the both municipal and contractor firms that are doing most of the road painting, and they typically have their own garages. They do their own work. They upkeep so a lot of them build their own machines, and then they maintain their own machines. So that's not uncommon as far as the people out there. It is typically a crew of 3 to 5 when they go painting. We could prospectively do it with 1. Right, you're in a cab, you're surrounded by steel, so you can go out there and you line it up and you paint. But however, we have some concerns about people running into the robot. Now, setting out cones is something we can do, but what's commonly done is to have a second truck, a large truck that they euphemistically call an attenuator. Right, because so the first car comes and hits the attenuator, reducing the damage to the lead vehicle. So it's probably 2 people, 2 trucks is what's going to happen. Yeah, but there is, in addition to manufacturing, there is, ongoing repair and maintenance of the vehicles themselves. But we think that we can probably save maybe 2 full-time equivalents on a road crew to go painting. Yeah, and by save, I mean include lives. Yeah. No question back here.
Yeah, have you ever thought about going on Shark Tank? Franchising your company out?
Shark Tank. Well, I'm not sure Shark Tank is really for real. I think it's one of these game shows that's already kind of pre-scripted. But nonetheless, the idea about franchising, yes, in order to get these machines out internationally, we expect to license their manufacture. So because we're not going to be building them in Akron and shipping them to Saudi Arabia. And so we expect that there will be manufacturing in different parts of the world. And that's what our friends in New Zealand are interested in, though they probably would ship to Australia. So something like that. Shark Tank in particular. I don't know that we can get on, but thank you for the thought.
Just one more question. I see one over here. If we want to get the mic over there.
Yeah, thanks. Just curious, from the business side, how is your funding rounds going in that journey?
Yeah, we've been extremely fortunate. There's been very good support here in Ohio. So we started off with Sam and I, opened our wallets and started our first self-funding. Some family and friends after that. There's a program called GLIDE. It's a state of Ohio funded Great Lakes Innovation Development Enterprise. I think we got $25K from them and then came back and got a phase 2. It's a $75K. We got a TVSF, another state sponsored one that was $80K. And then we got an NSF phase 1 for $250,000, and then we got an NSF phase 2 for $1 million. We also got some private investors, so we're up to about $2 million total at this point. We are about to go seek some additional funding, and we have a couple of partnering arrangements and discussions. So far, we've been able to meet payroll with our employees, but it's always like treading water. But yeah, we've been very fortunate, and the help out there has been very valuable.
Well, let's thank Professor Newman for his time today.
Thank you.
I love seeing that video. That was very exciting. So next up from the Institute for Smart, Secure, and Connected Systems, I nailed it. Yes, that's $1. And thanks, Jim. I would like to invite Chris Nuri up here to tell us a little bit more about what Isaacs is doing. Thanks, Chris.
All right. So, Isaacs, the Institute for Smart, Secure, and Connected Systems, that's a lot of words without the right context, could mean a lot of different things. So I want to focus primarily on the last two words in connected systems. For the most part, everything that we now know is a connected systems. The light, the phone, your TV, just about anything now is a connected system. Health systems, manufacturing systems, the systems upstairs in this building. And so Isaacs works in those particular areas, and we're multidisciplinary. So we do stuff engineering, we do stuff medical, we do stuff smart cities. We need to be smart about this, though, and we need to be able to do this in a secure way, because now that everything's connected, we've opened up a whole bunch of avenues for misuse, for bad intents, So that's part of it. Now, you've probably heard of IoT, or the Internet of Things. That's often what these connected systems are. So we define the Internet of Things as sensors and actuators embedded in physical objects linked through wired and wireless networks, unlocking opportunities for data-enabled decision-making. So again, this is all about how can we use data to collect, transmit, store, and then use that in a way that we can either present it to people, because this is all about how people can use the data to make smart decisions. Again, whether it be on a manufacturing floor or dealing with a neonate and understanding how their blood oxygen level is fluctuating throughout the day. So that's just a brief context setting in terms of what Isaacs and the fields that Isaacs works in. So, Isaacs, as I said, is the Institute for Smart, Secure, and Connected Systems, and we try to foster multidisciplinary efforts across the campus, but also throughout the community. And we're starting to engage in private and public sectors and identifying projects where we can bring in together faculty, students, and external partners to all work on a project and hopefully solve real-world problems. So we are very much the development aspect of the research and development side of things. We have primary focuses in core IoT or even smart cities. So the cameras and the sensors that you might see driving around the city, those are things that we will work on. We have a focus in smart and future manufacturing. Cleveland is a huge region for manufacturing, specifically around small to medium manufacturers. And they don't have the volume or the expertise to necessarily automate like you would think in a car factory. So how do you adopt as a small manufacturer smart technologies to improve your operations, to understand what's going on your shop floor and identify ways to become better, more efficient, and support even the workers in what they're doing? And then we also have efforts around connected health through partnerships with the local hospital systems as well as the School of Medicine. We're working in a variety of different ways, whether it be sensing or integrating with existing medical systems, and how can we, again, use that data that's already there that might not all be combined into making smarter decisions. You might have one system that is doing something around blood pressure and another system doing around EEG. How can we maybe combine that information and see if there's correlations, if there's other insights that we can build with that combined information. So that's all about who Isaacs is. Who am I? So I am not an academic. I have over 15 years in industry experience, and I have worked with small startups to large Fortune 500 companies, and I'm all about trying to support teams either in their operations and their practices, but also in their technical skills on how to solve problems. I'm all about building things, and there's no better place to be building things than ThinkBox. So I am the newly director of professional services and bringing that professional aspect. And like I said, we are sort of the development part of a research and development endeavor. I live on the second floor of ThinkBox, and we leverage ThinkBox for a multitude of different things, as well as just sort of being a part of the community. It opens up a lot of different serendipitous moments to have conversations and be able to talk with Ian, talk with the other crews on the third and the fourth floor that, you know what, we have this idea. What can we do here? What is this all about? Is that a smart idea? Let's go try it out. Like that's sort of the benefit of ThinkBox and why Isaacs has chosen to be here for a lot of these different projects. So we try to use ThinkBox as this living lab. And within this living lab, we have a multitude of different projects, and one of them is the Smart Manufacturing Innovation Center. So this is funded effort around the Department of Energy and through an organization called SESME. And our whole goal is to build out demonstrations of how manufacturers can adopt these smart technologies. One of them is we've installed about $200 worth of hardware, a little bit of software to collect occupancy and welder usage to identify ways that the welders can be better at their jobs. We talked with local manufacturers, and they said, I don't know even where to start getting data. What do I do? I've been told I need to spend tens of thousands of dollars and I need to collect all of this data. We're collecting two main metrics here. Is the weld station occupied? And is the welder in use? And just from there, we can open up and with a little bit of assumptions that if someone's in the weld bay, they're doing work, they're not eating a sandwich or anything like that. And we can then infer utilization. If they're burning what they call burning wire, then they're doing the value added efforts, because that's where it takes years of skill and practice to become a better welder. Well, if you're spending 3/4 of your time not welding, doing operations that they call fitting, okay, having that metric and to say, I'm spending 70% of my time doing things that I don't consider a value add, how can I take that information and either better support the welder and make sure that they're getting better plans, or the materials aren't right, like identifying the areas of where we can ask further questions and then maybe get more metrics or more information. Or maybe it's just a conversation and they say, you know what, these plans are garbage, I need them to be better. Like that's a really cheap way for a couple $100. And these are, this is something that is live on the cloud. We have dashboards that as people use the weld station here at ThinkBox, it pops up and says whether it's available or not. And we can actually see how people are using the welders. Another one is we are working again on the fourth floor with the CNC machine, and in a similar fashion, just understanding and taking very simple metrics around the environmental factors, so temperature, humidity, things like that, but also just machine usage. How much current is it using? And using that as a proxy for, is the machine in use? This doesn't have to be a smart machine. This could be a machine that was built in the 60s, has no idea of what a smart connected system is, and being able to retrofit these old machines into getting new metrics. And again, this is relatively low cost equipment. This is about, I think, $3,000 worth of equipment through our partners, and being able to do that, and it's a pretty quick install, connect, set it up to the cloud. We have a dashboard. We have a bunch of other projects here at ThinkBox, and I mean, it's the resources available here at ThinkBox have supported so many of our different efforts, whether it be 3D printing, rapid prototyping, being able to even go up to the third floor and say, hey, you know what, we're doing a lot of machine monitoring. Can we monitor your 3D printers? We want to build a dashboard there. So all of these projects have supported different faculty and student engagement. This is a lot of different experiential education opportunities, and it's kind of what we do at ThinkBox. That's Isaacs.
Wow.
I was short.
I think we have time for a few questions. Let's wait till the mic gets to you, but who wants to go ahead and ask the first question? I see a volunteer.
Uh-oh.
Not a volunteer. He made me promise to do this. No, but my understanding is that $200 monitoring of the welder, not only did you demonstrate it here at ThinkBox, but it has been transitioned out to companies that have found it useful. Is that right?
So we've had interest through other organizations. The one organization that we were working with ended up just sort of not being ready to do it. And that's where we get into, we think of these systems. These are systems that are technology, but also systems with people. And as they were going down, they go, oh, well, we want to do this. Okay, well, then how are we going to manage this and communicate this with the people? And they started to realize they weren't ready for that insight, either through the communications that they were lacking with the welders and all of that. So yes, there was sort of this light bulb moment of, oh, I can for relatively cheaply be able to deploy this. And then they've started to identify other problems along the system. And so they weren't quite ready for that. We have been deploying technology similar to what you see in the weld stations to one of our partners, Magnet, who deals with small to medium manufacturers and sort of adopting smarter technologies and all of that. And we've built out some demonstrations, or are building out demonstrations in their facility as well.
The one down on Chester.
Yep.
So we had a question over here.
Mine is kind of related to that. So I'm in school right now for my part-time MBA, and I'm taking an operations management class, and I'm like, oh, we just talked about what utilization means, so that's exciting for me. I'm like, I learned something. But I was thinking about, like, to the point of, like, translating it into, like, a manufacturing setting to scale, like, how you manage the communication of that to the team, because I could see people who are on the team are like, oh, now this computer's watching me, like, you guys think I'm not doing my job, like that kind of thing. There's like a human component of it, to your point, and how, like, one of the things we talked about in class, again, I'm just learning, so I'm not an expert, but it's just like sometimes like having, you don't want to have too much utilization, because then like you don't have the opportunity to respond to, things that come up in the system that you need to have. So like, will people feel threatened by that? And just, I don't know. I don't know if it's a question or a comment, or just like how, like ideas on how to present that to and maybe that's the problem that this company ran into. I don't know, that their team was not receptive to it or something. But.
They sort of weren't ready.
Yeah.
They weren't ready, and there are opportunities, again, as we think about being smart and secure, opportunities to use this data as a stick or as a way to lift up. And so are you using that as, why aren't you working harder? Right. Or is it, hey, I noticed that you're only getting 50% utilization. How can we support you?
Yes, it's like not enough to just develop the solution. It's like knowing how to train somebody to use it for good, and like understanding that psychological component of it.
And all the more in terms of, it's not all about collect all of the data. It's what metrics and what can we use either as proxies or as specific data points that support different hypotheses or questions or problems, and use that versus you can collect all of the data and we can sit there and say, oh, that's 95 degrees in a workshop. What decision is that going to help make?
Good question. We have time for one more, and then I think we're going to take a little bio break just for a few minutes. Does anybody have a final question for Chris?
Thanks, Chris. I was just wondering if you could elaborate a little bit more on like kind of the idea of the service model of the center.
Oh, sure. So we're relatively new, about a year and a half in, and so far through our networks, mostly on campus, we've been building out the technology necessary to support research. So we care maybe less about the results of the data and more of, is the data being transmitted? Is it correct? Is it verifiable? And things like that. We're looking to expand that sort of service model to include, again, through our network, because I come from industry and I've worked as a consultant in a broad range of different groups, is to start to work with partners, whether it be in the medical field, industry. Again, everything's sort of connected. So our options are quite broad. And even I've had conversations with individuals that are coming here to ThinkBox as outsiders, just wondering, how can I outfit a building with just regular environmental sensors? What's the necessity there? So there's opportunities all around in that regards. And we're, admittedly, we are figuring it out. Like there is some, because it's so broad, there are so many different things. And this is, again, because as we think of the whole system, it's also very difficult because the technology is a relatively very, very small part of it and often a solved part of it, right? A sensor that does humidity and being able to communicate to the cloud, that's solved. That's a commodity at the moment. How do I integrate that into a larger system for supporting decision making and all of that? So there is a consultative part of that service as well. So we are constantly looking for other opportunities inside and outside of the university space.
Wonderful, thank you. Thanks, everybody. Thank you, Chris, for joining us.
Mm-hmm.